right, so let's go ahead and start section 4 of unit 1. We're going to start understanding what to do whenever we have an I or a negative under the square root, which is an imaginary number. If you look at the bottom of page 8, that is your standards. It also tells you what the learning target is. It's just saying that we can define I as the square root of -1, or I squared is -1. So far, for all of our quadratics, we've had real number solutions. In other words, it's been something that is a real number. You can see it, you understand it, you don't get error in the calculator. But now we're going to look at something like this. We have x squared plus 16 is equal to 0. So to solve this, we're going to subtract 16 from both sides. So minus 16, that's going to leave me with x squared. This cancels out because plus and minus, the same number, gives me 0. That's going to equal negative 16. Next, if we're going to take the square root of both sides, we will get x is equal to the square root negative 16. If you put this in the calculator, you can't simplify it because of this negative that is up under that square root sign. All right? So something times itself is going to give me the number that's under the square root. So 4 times 4, if I do 4 times 4, it's going to give me 16. If I do -4 times -4, it's going to give me 16. And as you can see, neither one of those are negative. So let's just leave it at that for right now. All right, so what happens when you try to put the square root of -4 on your calculator? So if you have a calculator, I want you to try that and see what you get. When you put that in, you should end up getting an error. So that just means that this right here cannot happen, all right? So what you need to remember is that when you get this number, to get that number, it's going to be a value times a value, all right? Or you could say a number times that number, the same number, will give me what is under the square root, all right? So that's what we get. Now, when we take the square root of a negative number, it's not a real number. So in order to represent the solution, we use an imaginary number. So the square root of -1 is I. This right here lets us know that you can't put it in the calculator. So we're going to take the square root of -1. And we know that it will always be the answer. All right? So that, whenever you see the square root of -1, your answer for that will always be I. All right, so I want to show you a little pattern here. We know that the square root of -1 is I, as we saw before. Well, I is also I to the first, which we have at the beginning, okay? Now, I squared just means that we took and multiplied I times I, which is also the square root of -1 times the square root of -1. All right, now, anytime you multiply a square root of a number by the square root of the same number, you're going to get the number that is under there. So, for instance, if I had the square root of 3 times the square root of 3, I'm going to get 3. Oh, sorry, I wrote that wrong. I'm going to get 3. The reason being is, if I multiply these two together, I'm going to get the square root of 9, which is 3. So anytime I multiply a square root of a number by the same square root of that number, you're going to get the number that's under the square root. So my answer for that one is going to be 1. So I to the first is always I squared is always -I. I cubed is I squared times I. We know what I squared is. I squared is -1. So -1, we know that I is I. Right there. That lets us know I to the first is I. So times I. And that gives us -I when we multiply those two out. All right, I to the fourth. I squared times I squared. Well, we know I squared is -1. So -1 times -1. All right? A negative times a negative gives me a positive, and I end up with 1. All right, I to the fifth is I squared times I cubed. And the reason I know this is because I have the same base. Think back to the exponent rules. I have the same base. When I have the same base, I can add my exponents. So 2 plus 3 is 5. I know I squared is going to be -1. I cubed is -I. So if I multiply a negative and a negative, I get a positive, and 1 times I is I. All right, I to the sixth is going to be I squared times I to the fourth. Well, I squared, if we look back up here, I squared is -1. I to the fourth is 1. So -1 times 1 is going to be -1. All right, I to the seventh. We have I to the third and I to the fourth. I can add those two together, and it gives me 7. So I know that I've split it up good. All right, I cubed is -I. I to the fourth is 1. So if I multiply a negative and a positive, I get a negative. 1 times I is -I. All right, I to the eighth. So I to the fourth times I to the fourth. All right, we know I to the fourth is 1, so we've got 1 times 1. 1 times itself is 1. Now, I want you to look at this. I have 1, or -1. So I have I, -1, -I, 1, I, -1, -I. Sorry, it should be -I, not -1. So -I. And then we have a 1. Now, if I look at that, I'm starting to see a pattern. I1, I1, I1. Now, there's some negatives and there's some positives. If I look at this, I have a pattern. This repeats itself. So every fourth time it starts repeating. All right? Now, a good way to remember this pattern is it is I1, I1, but the ones in the middle are negative. All right? So go ahead and turn your page, and if you look on your page, there it is again, but I was explaining what was going on. All right? So you can look back and forth at this as you need it throughout the rest of this time. All right, so what pattern did we see? We had I1, I1. So every fourth time it repeats, as you can tell. So I1, I1. All right, but we do have positives and we have negatives. Well, the middle ones are always the negatives. So I1, I1, and negative in the middle. All right, so if we want to find out what I to the 65th is, we don't want to sit there and do tally marks. We don't want to sit there and go, okay, we know it's a pattern, so I to the 11th, if it's I1, I, and then 1, and that's going to be I to the 12th. You don't want to sit there and keep doing that, because that's just going to take a long time, especially when we get ready to do 244. So there's an easier way to do that. So I'm going to take, since we know that it repeats itself every fourth time, I'm going to divide by 4. All right? Now 4 goes into 6 one time. I have 2 left. Bring down my 5. 4 goes into 25 6 times. That is 24. And I'm left with 1. Now, the only thing I need to look at, I do not want to use the calculator. I want to do longhand division because I need a remainder. The remainder is all I'm looking at. I don't care about this number there. It don't matter to me at all. So I have the remainder of 1. Now I'm going to look back up at my pattern. All right? My sequence goes 1, 2, 3, 4. 1, 2, 3, 4, and it just repeats itself. So 1 would end up being I. So my answer for this, my value for I to the 65th is I. I'm just repeating that, okay? Now, 244 divided by 4, we're going to do the same thing. 4 does not go into 2, but it does go into 24, or 6, 24 times. It gives me 0. Bring down my 4. 4 goes into 4 one time, so that gives me a remainder of 0. So my remainder is 0. Now, if I have a remainder of 1, it's going to be I. If I have a remainder of 2, it's negative 1. If I have a remainder of 3, it's going to be negative I. Now, I'm not going to have a remainder of 4 because I am dividing by 4. So this is going to end up being 1. So when I have no remainder, that means at the end, it went into it evenly, and I need to use what the fourth one would be. All right? Now, if you want to make you a little list on the side of your paper to use over and over, you can. This will help you, just so that way you know what you're looking at and you know what the order is. But this is just saying remainder of 1, I have I. Remainder of 2, I have negative 1. Remainder of 3, negative I, and no remainder, I have 1. So that way when you get ready to do these, then you're good. All right, let's go ahead and simplify these real quick. So the square root of 4 is 2. It is a perfect square. All right, the square root of 8 is not a perfect square, so we're going to have to look at the factors. Well, I know it has a factor of 2 and a factor of 4. So if I just split them up, I know 2 times 4 is 8. So that's why I can split them up like that. Well, 4 is a perfect square. So that can be simplified to 2. And the square root of 2 is going to have to stay because it's not a perfect square. All right? Now, when you get ready to write this as an answer, though, the 2, the whole number, has to be up front. So I'm going to have 2 square roots of 2 as my final answer. All right, square root of 12. So I have the square root of 4, square root of 3. 4 is a perfect square, which is 2. 3 is not, so I'm going to leave it. Now you can factor this another way, 6 and 2, but then you can factor 6 on down to 2 and 3. Let me just show you real quick. 6 and 2. Well, 6 is not a perfect square, but I know that 3 and 2 and then 2. Remember what we said. If we have anything, 2 factors or 2 square roots that are the same and we're multiplying them together, it's going to be what's under the square root. So that's going to give me 2. And then I'm going to keep the square roots of 3. And as you can see, I got the same thing over there. So whatever factors that you use is fine. You just know that you have to break them all the way down to see, make sure nothing goes back together. All right? Now, if we look at 2 square roots of 32, 32 is not a perfect square, but it has 8 and it has 4. Now, I want to leave that 2 out front because it's being multiplied by the square root of 32. All right? So, we have 2. 8 is not a perfect square, but it can be multiplied by 2 and 4. And then 4 is a perfect square, so 2, and that's being multiplied as well. I want to go ahead and multiply my whole numbers together. So I have 4, and then it is multiplied 2 square roots, or square root of 2 times square root of 4. Now I can see if I can break it on down. 4 is a perfect square, so I have 4 square roots of 2 and 2. Now again, I want to take and multiply my whole numbers. So 4 times 2 is 8, and the square root of 2. And that is my final answer, because 2 cannot be simplified down anymore. All right, now we have 45. So the square root of 9, square root of 5. 9 is a perfect square. 3 is its square root. 5 is not, so we're going to leave it. All right, next we have 60, which is 12 and 5. Now we know 5 is not a perfect square, but we know 12 can be broken down. So 4, 3, and 5. All right, so this one is 4 is a perfect square. Its square root is 2. So we go ahead and simplify it. Then 3 is not a perfect square and 5 is not a perfect square. So we're going to go ahead and multiply those back together. That's going to give me the square root of 15. And that's going to be our answer. All right. Now let's go ahead and do these. The only difference is these have negative. Now as you saw before, up here before, I was splitting these up. Okay, I'm going to do the same thing with a negative. All right. I know that 81 and negative 1 will give me a negative 81. So I'm going to take that negative 1 out. And then I've got something I can work with. Because if I was to plug negative 81 in my calculator, I would get error. So negative 1 is going to be I. We found that out at the beginning. So the square root of negative 1 is always going to be I. Square root of 81 is 9. Now I have this simplified. The only thing is when I get ready to write this, my whole number has to be up front. So my answer is going to be 9I. All right. Next, I have the square root of 60. So let's do this, negative 1 and then 60. All right, so we have I. We know that. Then we're going to have 12 and 5. 12 can be broken down to 4, 3, and then we're going to bring that 5 down, and we have I here. All right, 4 is a perfect square. It is 2. 3 and 5 are not, so we're going to put them back together, and we have I. Now, we need to make sure that this is written correctly, okay? So the I is going to go after the whole number, but it's going to go before the radical sign. So we're going to have 2I square roots of 15. All right? Now, don't be stressed about a fraction. It's not any different, I promise. All you're going to do is take the square root of 9, the square root of 16. So the square root of 9 is 3. The square root of 16 is 4. And we have our I. Now we need to write this correctly. So it'll be 3 over 4 and then I. And that will be our answer for those 3. Now, don't do these yet, because we'll be getting into adding and subtracting imaginary numbers and stuff shortly. So I don't want you to do those quite yet. All right, so let's go ahead and do these. I'm going to take this out, and it's going to end up being I. Square root of 72. We have square root of, we end up with the answer of 6 square roots of 2. Now we need to write this right. So we end up getting 6I square roots of 2. Now once we pull that negative 1 out, you have a positive. So if you use the calculator, that is fine. I'm good with that. So we have negative 1, we have square root of 52. So when you put the square root of 52 in the calculator, you're going to get 2 square roots of 13. And then, of course, this is your I. We need to make sure we write it right. So 2i square roots of 13. All right. We have the square root of -1, square root of 18. All right. So then we're going to take 9 and 2 as your factors that we'll simplify down. 9 is a perfect square, so it's 3 square roots of 2. And then we have the I, so it'll be 3i square roots of 2. All right, if you have any questions about that, you can ask me in class tomorrow. It's not a big deal. All right, now these you cannot use a calculator because we want a remainder. And remember, have a remainder of 1, we get I. 2, we get -1. 3, we get -I. And no remainder, we get 1. All right, so that's our little trick over there. So 84, we're always going to divide by 4. 4 goes into 8 twice, leaves me with 0, bring down my 4. 4 goes into 4 one time, I'm left with 0. So my answer for this one is 1 because I have no remainder. All right, 50 divided by 4. 4 goes into 5 one time, I have 1 left, bring down my 0. 4 goes into 10 twice. 4 times 2 is 8. And that leaves me with a 2. So my remainder is 2. My answer is going to be -1. I'm going to do 4 and 78. 4 goes into 7 one time. I'm left with 3. Bring down my 8. 4 goes into 38 9 times. That's 36. And I'm left with 2. So my answer is going to be -1. Then 4 into 31. 4 does not go into 3, but 4 does go into 31 7 times, which gives me 28. When I subtract those, I have a remainder of 3. My answer is -I. So all I'm doing is I'm looking at my little rules, and I'm checking to see. Now, if you have any questions, write them down, jot them down, make a little note of them somewhere. When you get into class, I will be glad to answer those for you.